The first session of MISP. The first session of
Session chairs are requested to please on your video.
To all the good afternoon to all the respected session chairs, dignitaries, and the presenters of on behalf. I would like to welcome on behalf of Department of Computer Science and Engineering, NIT Raipur, and
just one. I'm right.
Sir, can I continue?
Yes, sir. Continue. Dr. Reddy also joined.
Okay. So on behalf of Department of Computer Science and Engineering, National Institute of Technology, Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, I welcome all the respected session chairs, participants, and dignitaries in the track 1 of as machine learning application and use cases as session 1, role of machine learning in cyber security. Before we start the session, it's my pleasure to introduce our esteemed session chair for our first session. I will start with Dr. Sumit Srivastava. Dr. Sumit Srivastava is professor in Department of Information Technology, Manipal University, Jaipur. He has done his MCA from Birla Institute of Technology, Mesra, Ranchi in 2003, MTech from the Karnataka University, PhD in data mining from the University of Rajasthan in 2009. He has 19 years of teaching and 14 years of research experience. His area of research involves algorithm, data science, knowledge discovery, computational agent-based modeling, hybrid dynamic system, decentralization, decision-making, feature extraction, process mining, and engineering education. Dr. Sumit has also been invited as a speaker in algorithm, machine learning, and information knowledge discovery as various short-term courses. He has published 70 plus papers in SCI, Scopus, and peer-reviewed journals and conferences in international and reputed journals and conferences. Now, I would like to introduce our next guest, Professor Damodar Reddy. Professor Damodar Reddy Idla is working as Associate Professor in the Department of Computer Science and Engineering, National Institute of Technology, Goa. He received his MSc from University of Hyderabad.
Saurabh?
Yes.
When you are introducing to honorable session chairs, so yes, you are expected to share their welcome slide also.
Yes.
Okay.
Yes.
You are visible only on screen.
Okay, sir. So Dr. Reddy received his MTech and PhD degree in computer science and engineering from Indian School of Mines, Dhanbad in 2009 and 2013 respectively. His research interest includes wireless sensor networks, cognitive neuroscience, brain-computer interface, medical imaging. He has published more than 150 research articles in reputed journals and conferences. Now I would like to welcome Dr. Swendu Roop. Dr. Swendarup is currently working as an assistant professor in Department of Computer Science and Engineering in International Institute of Information Technology, Bhubaneswar. He has obtained his MTech and PhD degree in Computer Science and Engineering from Jadavpur University and NIT Rourkela, respectively. Professor Roop have more than 17 years of teaching experience. His research interest lies in the area of image and video processing, computer vision, machine intelligence, video synopsis, medical image analysis, object and sense recognition, virtual reality, historical heritage, human pose and activity recognition. He has more than 70 research papers in reputed journals and conference proceedings. Now, I may request all the session chairs for permission to start the session 1. These are the list of paper number 48, 244, 306, and 336, and 429. Sir, with due permission, can we start the session?
Yeah, now
Yes, sir.
floor is of session chairs. Now please you conduct this session. The paper IDs and paper titles and name of presenters are mentioned. Please, sir. Your order may be changed because we have not mentioned the specific time. Rather than a specific time, we have mentioned the time slot. And all these papers are supposed to be present in this time slot. So we may change the order, but we will try to do in this way as it is mentioned in the list. So please, can you proceed?
So we'll start with paper ID 48, sir, first. Are the presenters ready?
Yes, sir. I'm presenter for paper number 48, sir.
So the other session chairs. So shall we start, sir? I think Sumit, sir, and others. Yes.
Shall I share my screen, sir?
Yes, yes. Present
Yes.
of paper ID 48. Please share your screen.
Yes. Good afternoon, respected session chairs and everyone. Thank you for joining today's session on role of machine learning in cybersecurity. I would like to introduce myself. My name is Repala Venkata Bhavana from Shastra Deemed University. My co-authors are Yajnasai and Dr. Sudha, also from Shastra University. Today's presentation is about detection of fraudulent credit card transactions using advanced light GBM approach. First, I would like to go through the background of the paper which we have presented. Online payments and credit card usage has become part of our lives. Digitization has made our lives much easier and more convenient. So people are they are using online payments every day. And the use of credit card for online transactions is increasing day by day. And so is the fraud associated with them. Fraudulent credit card transactions not only affect the individuals, but also affects larger companies, businesses, and banks, causing them huge losses in financial terms. The fact that only a few number of fraudulent credit card transactions are found in a huge number of credit card transactions every day, the detection of these frauds has become difficult by using machine learning techniques. So keeping in mind the challenges faced by the machine learning techniques, we have studied various papers. These are the few papers and I have summarized them, what they have proposed. And we found out few demerits from these papers, that the data the data sets which they have considered are class imbalanced. There is a class imbalances in them, and they have not pointed out that problem clearly. And in the paper number 5, which I have mentioned, uses the detection algorithm called LightGBM, but it fails. It has a demerit that it uses grid search hyperparameter optimization technique, which is inefficient in terms of computational power and time. And for the paper number 6, random forest naive-based logistic regression and multi-layer perceptron were compared with each other for classifying transactions as fraud or genuine ones. They have only considered few parameters, to be exact, 3 evaluation metrics, that is accuracy, precision, and recall, but they have not mentioned other metrics which influences the performance of a model. And the accuracies gained by these methods is very less when compared to the LightGBM, which I have mentioned in the 5th paper. By considering these papers, we have concluded with a problem statement that the identification of these fraudulent transactions has become important, influencing the increased use of e-payments. Hence, there is a need for efficient and effective methods for identifying fraud in credit card transactions. The proposed method, which we have mentioned in our paper, includes LightGBM and the Bayesian-based hyperparameter optimization technique. Together, we have termed it as advanced LightGBM. Then the advanced LightGBM's performance is compared with other classical machine learning techniques like decision tree, random forest, SVM linear, SVM RBF, KNN algorithm, logistic regression algorithms by using 2 different real-world data sets. Our proposed methodology has 4 stages, 4 major stages in that. Data pre-processing, feature selection, performing advanced LightGBM, and evaluation metrics. Our framework for the proposed methodology is shown in the flow diagram. In data pre-processing is the first major step in our proposed methodology. We have taken 2 real-world data sets which are imbalanced. That is, the number of fraudulent credit card transactions are very less when compared to the number of genuine credit card transactions. An imbalanced data set tends to give poor accurate results, and it gives poor accuracy also. So to tackle that problem, we have used cross-validation to get accurate results. Next is the feature selection, which is a crucial stage which improves the classification, performance, and fraud detection. Information gain, which is a popular feature selection technology, was used in our proposed method. Information gain is used for enhancing the accuracy of the model. And for calculating the information gain, we have calculated the entropy of each features of the data set. The features with the highest information gain actually influences the model's capability of detecting fraudulent credit card transactions. So we have considered only the features having the high information gain values, and those features are used for training the model. Next is the performing advanced LightGBM, which is the core heart of the proposed methodology. LightGBM is optimized. LightGBM's hyperparameters are optimized using Bayesian hyperparameter optimization technique. The hyperparameters like max depth, num leaves, learning rate, max bin are chosen. Then these hyperparameters are tuned within their ideal ranges, and the final results after this optimization is given to the uh, hyperparameters of the light GBM during evaluating the performance. Next major stage is the evaluation metrics, in which the performance of the advanced light GBM is calculated. We chose to use a k-fold cross validation due to the class imbalances in the data set. While evaluating the proposed method with various values of k, we found that k is equals to 5 gave the better results than other values of k. So it is the 5-fold cross validation which we used for tackling the imbalance in the data sets. As it is very highly imbalanced data set, we chose to use a smooth technique during the 5-fold cross validation. The performance of the advanced light GBM is compared with other algorithms in terms of accuracy, precision, recall, F1 score, and AUC scores. These are the ROC, AUC, and precision recall curves for the advanced light GBM for dataset 1 and dataset 2. It is observed that when compared to the other classical algorithms and the advanced light GBM, the accuracy of advanced light GBM was 99.92% for dataset 1 and 97.59% for dataset 2. Which is higher than the other algorithms. And even the ROC, AUC graphs of advanced light GBM was more better than the other classical algorithms. So from the above results of the experiment, we show that the proposed method, that is the advanced light GBM, outperforms all the other machine learning techniques. The findings further emphasize the relevance and value of using an effective parameter optimization strategy in improving detection performance. Thank you for giving us this opportunity for presenting a paper at MISP. Please feel free to ask any questions.
No, Dr. Bhavana, can you hear me?
Yes, sir.
Yes. So now when you have basically you're proposing a credit card fraud detection type of model using these
advanced
type, some data boosting machine and then some Bayesian optimization model.
Yes.
Now, what is the main contribution in this model? Because now what I've seen, like it's a good framework where you are exploiting the Bayesian model, the optimization model for optimizing the parameters from the light GBM, the gradient boosting machine, right?
Yes, sir.
Now,
Yes, sir.
what is the main contribution in this paper?
The main contribution was to show that the performance of this advanced light GBM it is higher than the other existing algorithms. So it is good to use the advanced light GBM.
But there are plenty of other classifiers and ranking models already exist, right? Similar to, because this is merely a decision tree based approach when you're going with this. But there are plenty of other complex deep learning models and all exist, right? Because some kind of training learning models, these type of problems can easily be solved with when you're compared with some random forest classifier and other type. Obviously, you will have some little accuracy, but we have not seen any advanced machine learning models compared with your model. How many models you compared? Your approach with?
Around 8 models, sir.
Which are those?
Decision tree, Gaussian naive Bayes, KNN, random forest, SVM linear, SVM RBF, logistic regression.
So most of them are basic and conventional classifier models, like when you are going with for comparison. Have you explored any deep learning based architectures for such a credit card fraud detection, or some extreme learning machine, etc.?
No, sir. We have only like compared with this algorithms.
So whatever the models you have chosen for comparison, you have got the accuracy, but you have not tried beyond these models, or you have tried with some other model where you have not got the accuracy, and you have kept only these models where you have better accuracy in the paper.
We have only tried with this models.
Okay. When you, in your literature review, we have seen some four, 5 papers. We just go back to that slide.
Yes, sir.
Yes. Now you have not seen any other because we have seen some conventional perceptron models, etc. So you have not seen any deep learning based architectures for this.
No, like we have only gone through the accuracy part. We have only focused on the performance, and we didn't really check on the other deep learning techniques. So while comparing these papers, we found LightGBM has the most, like it has the higher accuracy and performance than the other models.
Okay. Can you go to feature extraction slide?
Yes, sir.
Feature selection. Now you are tried with information gain, right?
Yes, sir.
Now there are plenty of other feature extraction models, the feature selection and extraction. Now,
Yes, sir.
better information gain, we have better models exist, like even if you go this autoencoders, etc., etc. Then you could have got even better accuracy, right?
The information gain is actually a popular feature selection, and it's also easy to use than the other complex feature selection techniques. And information gain
Recording has stopped. This meeting is being recorded.
So what Dr. Reddy has already suggested. So now in a very this competitive age for this particular area is concerned, the study of deep learning is very, very essential to that particular field. Because in your paper, in that paper, you may not have exploited this thing. In your paper, you may have investigated some kind of machine learning techniques here. So one of my very basic question is, for this feature selection, you have suggested information gain. So have you tried with mutual information? I think this is a better alternative as compared to your what information.
Yes, sir. We have actually tried with mutual information gain. It gives similar results.
Okay.
So we thought of going with the information gain that uses entropy.
Okay, what feature extraction technique you have used? Because these are the selected features. So you have selected the dominant features. So what is the existing feature extraction technique you have used in your work? Because initially you have extracted some feature. From that particular feature, you have to select the dominant feature or the optimal feature. What is the feature extraction technique you have employed here?
We have only used information gains. We didn't use any feature extraction.
You didn't go for any feature extraction.
No, sir.
Okay, in one slide you have mentioned that is the hyperparameter optimizations. So
Yes,
what is the criteria function for this hyperparameter optimizations? So which parameter you have optimized here?
LightGBM's hyperparameters.
Okay, what is the criteria functions? Means what is the stopping criteria? Where you will stop these algorithms? What is the stopping criteria you have used?
Yes, we have used precision as the stopping criteria. For about 15 iterations among the parameters which gives the best precision.
After 15 iteration, have you studied whether that particular graph, what you have been done, is stable, or after 15, even if it more improved? Have you studied?
Yes, sir, we have studied, and there is no further improvement in the method, sir. So the best is 15, and we have tried with more iterations, and it's not increasing.
Okay, thank you very much.
Can we start the next participant's presentation? Paper number 244.
Yes, yes, sir.
So,
Sir, can I share my screen?
okay. Manish Kumar, you can now share the screen.
Okay, sir. Sir, is my screen.
Yes, your screen is visible now.
Thank you, sir. Can I start, sir?
Yes, please start.
Yes, yes. So, good afternoon, everyone. So, my name is Manish Kumar. I'm doing my MTech research from National Institute of Technology, Karnataka, under the guidance of Dr. Elvin Roshan Pace. And I'm presenting my paper on topic machine learning based techniques for phishing URL detection from TLS 1.2 and TLS 1.3 traffic without encryption. So in the following slide, first we cover the introduction, past statistics, then we share some past anti-phishing techniques, then we discuss about methodology and results. Finally, we conclude our work. So phishing is a fraudulent technique used by the attackers to get the personal information of victims, such as password, credit card details, etc. And every sector, whether we take financial, health sector, then e-commerce, everyone using the internet services. So all these services are come with comforts to the users, but the risk of phishing attacks also increasing. In past statistics, I saw how fast they are increasing. So in our work, we developed a machine learning based approach for detection of phishing URLs based on the feature extracted from TLS 1.2 and TLS 1.3 encrypted traffic. And there is no past work that has been done to detect phishing URL from encrypted traffic without decryption. So these slides are the past statistics, and these statistics taken from the anti-phishing working group reports from 2005 to 2020. So as we see from 2005 onwards, the unique phishing sites are detected and they are increasing very fast. 2016, it is crossing around it is around 14 lakh, and 2020, which is a pandemic, it is touching around 15 lakh. So this shows the importance of the anti-phishing techniques, which can help in reduce the risk of phishing attacks. So many anti-phishing techniques exist, and they are mainly characterized in three categories: the content-based techniques, then list-based techniques, and URL-based techniques. In the next slides, I will go through each techniques and some literature papers which have used this approach for detection. So first technique is a content-based technique. So in content-based techniques, the feature are extracted from the images of the website, then feature from source code and hyperlinks. So as in shown in table 1, in the reference 1, the author used two methods like domain keyword extraction time invariant keyword extractions, and they extract the keywords not only from the visual on the browser, but they can extract from the pages which are linked with the website, and then they use this keyword to search on the Google, and whatever the result they got, they compare the target site with that result. If the site is found in that results, they declare it as a legitimate, otherwise they declare it as a phishing sites. And because of this, they misclassify some legitimate sites, and also they have a dependency on the third party site. In the second reference also, the author used the optical character recognition. They take the screenshot of the sites, and then from the screenshots they extract the keywords, then they search in Google, and after that the result they classify whether the given target site is a phishing or not. So again, they have a dependency and high processing time they require by this approach. So the second one is the list based approach. The list based is are only two types of list one is blacklist and other one is a whitelist. Blacklist contains the phishing site which is already identified as a phishing site, and the whitelist contains a list of legitimate sites. So in the table to reference third. So the author has used two filters. I mean, at first level, what they did, they used the blacklist filter where they first check the target site, which is a suspicious site in the list. If they found it is in the list, then they declare it as a phishing site. Otherwise, they use the heuristic second level filter where they extract feature from the URLs, and on the basis of that, they declare whether it is a phishing site or a legitimate site. So here also they have a dependency. They have to maintain the list. So but they have this technique is fast. And in the fourth reference, the whitelist based technique is used. In this, the sites author compare the suspicious site, check the existence of the suspicious sites in the whitelist. If it is found, then they declare it is as a legitimate site, otherwise they declare it as a phishing site. Again, the maintenance of list and dependency of third party services is there for the detection of phishing URLs. So, and next approach is URL based approach. In the URL based approach, what the features from the URL, full URL or the host name extracted, and on the basis they classify the phishing URLs. So in table 3, the reference 5, in this the author extract features from the URL and fix heuristic they calculate. Then they use this heuristic, compare with the threshold, and make the decision on whether the site is a phishing or not. So because of these, sometimes they misclassify legitimate sites, and also dependency on the third party services is there. In the reference 6, in the next slide, I will show a table, means host name based feature they extract from the URL. So this is the table. So they extract the features from the host name, like at the rate in the host name, count of digit in host name, average word length, then the length of host name, fish hinted words. These features they extract from the URL, and then they train the machine learning algorithms on these features, and on the basis of these features they classify whether the site is a phishing or not. So and in our work also, what we did, we also derived some of the features from the TLS 1.2 and TLS 1.3 encrypted traffic, and then we classify that whether the URL is a phishing or not. And we are trying to our work with detecting the phishing URL based on the features from the TLS 1.1 and TLS 1.3 encrypted traffic without decryption. So this slide shows the architecture of our proposed work. In the next slide, I'll explain each steps. But here we can see what is the flow, means how we classify our suspicious sites. So first we kept for the input URL, which is suspicious URL, we capture the TLS 1.3 and TLS 1.3 traffic. Then we convert into the JSON file for feature extraction. Then we prepare one feature vector, which is given as input to the already trained machine learning algorithms, and machine learning algorithms will help in classify whether the input URL is a phishing URL or a legitimate URL. So these are the steps. Like input URL is a suspicious URL, which is classified by our trained proposed model. And for capturing TLS 1.2 and TLS 1.3 traffic, we implemented Python program, and we captured the traffic for this suspicious URL. Then we convert this TLS 1.2 and TLS 1.3 traffic into JSON file. So what happened in TLS 1. During the handshake only, the two client hello message and server hello handshake is happened, and in that client hello message there are many parameters, which are some parameters are encrypted and some are unencrypted. So we target that unencrypted parameters, and we extract the features. We drive the table which I have shown in previous slides. We drive some of the feature from client hello message, from the content of the client hello message, and on the basis of their features we prepare a data set and train our model for the classification. And we use various machine learning algorithms to check which machine algorithm is performed best on our proposed model. So the results. So as earlier I said that there is no public database, and this is the first work based on the encrypted traffic for the classification of phishing URLs. So we prepared a data set for the phishing and legitimate sites. We use the fish tank and Alexa for collecting the phishing site and legitimate site URLs, and then we perform two experiments on our data set. In experiment one, we studied various machine learning classifiers, how they perform on our data set for the classification of URL. And in experiment two, we studied what individual feature, means if we trained our model with a single feature and how much accuracy, means how it behaved for the classification of URLs. And we, for evaluating performance, we used our traditional metrics like true positive rate, false positive rate, true negative rate, and accuracy, precision, and X scores are used. So this slide shows the results of our experiments one. So as we can see, like logistic regression, SBM, RF, random forest. So in all this algorithm, like logistic regression, we are getting 82.5 accuracy. For SBM, we are getting 87.2, and random forest, we are getting 88.2. And XGBoost and LightGM give us the 89.6, which is the highest accuracy. And the XGBoost outperforms the LightGBM in terms of true positive, false positive rate, and precision F score. And in the experiment, this HF2, these all are derived features, which I have shown in the table. And we trained our different classifier on each feature, and then we are getting for HF2 we are getting 63.9 accuracy. For HF3 we are getting 60 highest accuracy of 69.9. And for HF4 classifier, random forest, XGBoost, like GBM give us 60.7 accuracy. And for HF feature HF5 we are getting highest of 67.1 for light GBM. And HF10 we are having 69.2 as the highest accuracy for 4 classifier. HF11 giving us 64.46 accuracy for all our classifier. And this is the NOS, which is the number of servers. This is a new features we are added by us. This gives 67.1 accuracy for XGBoost and light GBM. And so this is a comparison why means our technique are better than others. Means content-based techniques, MISP-based, URL-based, and our model. So detection of zero-day phishing attacks. So all techniques except the list-based are not able to detect phishing zero-day, which are phishing sites, because they are maintaining the list. And if that URL doesn't exist in the list, then they are not able to classify that site. Fast computation is another one. So content based, using the optical character recognition, and they means from images they extract, so they are slower. And other list based and URL based and our model are faster than these techniques. And third party services, so our model is not dependent on any third party, as I shown in the literature survey also, that these sites are using like Google APIs they are using to get the result, and on the basis of the result they classify. So we are not using any third party services. And we also, none of the like above three approaches are used extract any features from the encrypted traffic. So our model only extract the features from encrypted traffic for the classification of a URL. So in our work, we developed an efficient machine learning based approach for detection of phishing URLs from TLS 1.1 and TLS 1.3 encrypted traffic without decryption. And as I earlier said, it is not dependent on any third-party services, so we can deploy it in any environment and make the and help which help us in the classification of the phishing URLs. So these are the references which I have followed. Thank you so much for inviting me for the presenting my work on phishing detection, and thank you so much. And feel free for any questions.
Munish, can you hear me?
Yes, sir. Yes, sir.
Yes. Now see, basically, like you're proposing a phishing detection model, right? Now,
Yes, sir.
will it work in real time?
Yes, sir. Real time. We in the real time, what we can do, we can make up one module like gateway module or something else.
Because what I've observed is like we are using some feature extraction models there, just observing the traffic. And once you make the data set ready, you're going to observe that and say that these are the possible phishing attacks that we have to identify. But whether when you have a large, I mean, when you have heavy traffic, then will you be able, your model will be able to capture such an amount of large traffic data and then make the feature extraction in real time and then give you the desired accuracy.
Sir, so that we haven't tested yet. So it's how for the last traffic is how we.
Because now these type of phishing attacks, mostly it happens in real-time system. Then I think
Yes, sir,
your model,
definitely.
when you, because your model, because the data set you're creating after collecting the traffic data, right? When you observe the network traffic. So how it will work, and that really depends on this particular aspect. Next thing is feature
So
extraction,
means,
how you are performing.
sir, feature extraction means we use the means for our experimentation we use like for capturing we use Python programs. So we capture the traffic and then we convert that into JSON. From JSONs we extract the features and we analyze for our, in our research we use the Wireshark tool for complete analysis, which features help us in the classification of URLs. So
So other than the small part of features related, what else the machine learning part in your model? Because your machine company is a machine learning based phishing detection model, right? Where exactly? Because
yes,
I've not seen a lot of machine learning models here. Justify your machine learning contribution here.
so some because the in the literature survey also machine learning approaches, many author used machine learning approaches for detection of phishing.
Yes,
So
yes,
we are
many
also
have used, but in your model, where exactly machine learning you are exploiting this?
after means after the feature
Onwards.
extraction means when yes, sir. So after the
Yes,
feature
tell me.
extraction means someone if yes.
Continue.
Means
Continue.
yes, sir. So once if I take a case means some user hit the malicious links on his browser. So what happened? So first we capture that traffic and extract the feature from the JSON file. Then these all the features we give as a feature vector as an input to our machine algorithm. So here the machine algorithms which is already trained, so help us to classify whether it means that this URL is a phishing or not.
I've understood. Now, what I'm saying is once the feature vectorization is done, then now see specific to type of attacks and type of URL, what is in your model, accordingly you have to select the suitable machine learning model, right? So how do you identify for every type of attack you're going to use the same machine learning model? How do you identify that?
So no, sir. Actually, so that's why we are performing the, on different classifier. We have performed our experiments. So XGBoost is performing better than other models. So we will miss we are.
So some kind of ensemble modeling you're using here,
Yes, sir.
some kind of ensemble
No,
approach you are
and
using
assemble.
here.
No, and assemble. I'm not using, sir. And assemble we are not using.
Because my only doubt was that machine learning, when you are using, once the features are ready, then how do you select the suitable machine learning model? That makes me confusing here. Next thing
Okay,
is
sir.
for some unmodeled type attacks when you are talking about, like not exactly DDoS type. Some, because now when your model is completely relying on the traffic data that you are capturing, when there is some unmodeled attacks comes on real time, how your model works, like untrained type models.
Untrained. Sir, I was untrained. I didn't get, sir.
For example, see, you are extracting some features and making some machine learning models and getting the accuracy at the end. Now, all of a sudden,
Yes, sir.
some new type of attacks. Some then you are going to see the possible features extraction. But how do you perform that type of extraction?
Sir, sir, we are targeting some URL means URL phishing means new attacks.
Because such type of attacks, it will make you exceeding the capacity to handle such multiple requests, right? Then how your network
Yes.
traffic can be handled over?
So means so like for handling that one, so we can many means round robin algorithms. So we so distributed computing we can use means sir. So that one is a different part only. So means this so that is the part where we can deploy at the gateway. So how we manage the traffic. So that part is means different only.
Okay. So just take care of this machine learning part. That's all from my side. Sven sir, I think maybe you can take.
Okay, Munish, am I audible?
Yes, sir. Yes, sir.
Okay. this specific machine learning algorithm means what model you are going to take. Is it generalized for all kind of your features what you are doing with? Have you tested on that?
Sir, generally,
Generalized means once a particular model has been trained,
yes, sir.
so what data are not being used during the training in the testing time? What is your segregation of training and testing in your work?
Recorded.
Sir, 80 and 20%.
Okay, suppose I'm talking about the 20% of data or any real-time data is coming. So is your model is generalized to deal with all this kind of data? What is the performance?
Yes, sir. Yes.
What is your observation?
Sir, it is. Sir, means it is generalized only. So because now everyone is using like TLS 1.0 and TLS 1.3 protocols only. So when the client hello means this is a so during the handshake only the format is same is that the parameters which are so client and server are exchanged are fixed means they have carry some value during the handshake. So we only from that we extracting the feature. So means it is generalized. When the request came, many parameters are in the traffic comes for the TLS 1.0 and TLS 1.3 protocol. From that only, like if I can say this cipher suit exchange is there. Means client is giving 16 to 17 cipher suit, and from the server it is selecting one. So like that, other features are like server name indications are there. So that features have carry some value. So from that only we extract the feature. So it is generalized. So it is not means like for specific only. So so whatever the parameters comes in the handshake, we used that for the classification.
Have you exploited any kind of deep learning technique? Because one of the major issues of this traditional classifier, what we are talking of, because you are making URL detection. So the volume of the data is very huge. So
yes,
have you exploited or have you thought of any kind of deep learning methodology? Because they might have worked well as compared to this traditional classifier.
So, yes, sir. So in our future work we will means exploring the deep learning and the new features which can help in increasing the accuracy of our model.
Okay, another question. Maybe for some time I was disconnected due to some network issue. So once you have been extracted from JSON file, so exactly
Yes.
what are the relevant features here? What are the relevant features here? Your work will be relevant features. Means what are they?
Okay, so this is the table means so like sir count of digits in the like server name indications are one of the extension uh, in client hello message. So they carry the server name and the number of server list is there. So these features and in the server name is the host name is coming. So like HF2 count of digit in the host name.
So
we count the digit in it. Then
all these 16 features you have been used in the model?
no,
Or you have
no, sir,
selected
no,
few?
not selected features. Sir, only selected features.
So how could you done the feature ranking? So how could you know done the feature ranking out of the 16? So
Yes, sir.
as per the rank of the features.
Sir, we calculate the accuracy for them. Sir, so most accuracy we are calculating for these features and the features which give us the means better accuracy, we selected that features.
Okay, okay, thank you very much.
Munish, I have one single question for you. I'm audible?
Yes, yes, sir, yes, sir.
Munish, you are using out a JSON-based method where the JSON path and JSON auto, these are the two features for getting the outputs. Now, on the base of the JSON file, which is a PCAP file, from PCAP to JSON and JSON to the feature vector.
Yes.
Now, they do not allow to generate an output, a customized output. So what's the technique that you're using out for getting your customized output from the JSON file?
Sir, so means the JSON from PCAP we can convert into the JSON file. So whatever the in the PCAP file, so in the JSON they are coming like, so we can convert in any format like PCAP, XML, JSON, any format we
But
can
it
convert.
is a
So
predefined
from
one.
the
It's a
JSON,
predefined one. You cannot customize what has been generated as a JSON path or a JSON auto file. So how you're
yes, sir.
customizing
So
this in terms of the feature vector you're getting out?
So we are not customizing. We just pass the JSON and whatever like I earlier said, means like server name, indication, extension. So these keys are appearing in JSON. So we pass one packet by packet, and from that we extract the whatever the value corresponding to the key is there. We extract that, and then once we extract all the features, then like digit counts in that host name. So then we on every features we prepare a feature vectors. How many digits are there? What is the length of highest means largest word is there? Then how many words are there? So all these features we prepare from this we prepare our feature vector. So we made one Python script which did all this job, means from extracting from JSON and then prepare a feature vector.
Fine. Thanks, Manish. We can move to the next presentation.
Thank you, sir.
Paper ID 306, Mrs. Dipti Sisodia. Please share your screen.
Yes, sir. Sir, is my screen visible?
Yes, continue.
A very good afternoon to all the respected ones present here. Myself, Deepthi Sisodia, research scholar, NIT Raipur, under the supervision of Dr. Dilip Singh Sisodia, sir. My paper ID is 306 and titled as Evaluating Feature Importance to Investigate Publishers' Conduct for Detecting Click Fraud. This is the outline which I will cover in my presentation. So starting with the introduction, online advertising is one of the most popular sources of revenue generation for different commercial entities. So figure 1 shows the ecosystem of online advertising, where we can see that the main role has been played by the advertiser, the ad network, and the publisher, where ad network acts as a mediator between the advertiser and the publisher. Ad network is the one, advertiser is the one who create advertisements for their products or promoting ads, while the ad network is the one who store advertisements provided by the advertisers and deliver them to the publishers upon request, while publisher is the one who provides the platform to display the advertisement on the websites. Thereby, the user generate clicks or view the ads as per his need. Few of the advertisers also reach to the users directly through online advertisers. So this is the online advertising ecosystem. Now here comes the literature survey, which I have gone through performing the experiment, where all these literature survey are basically focusing on designing an effective fraud detection model towards identifying the fraudulent publisher based on the clicks generated by them. So here the main focus of all these papers was to design or to identify the features which are so that we can identify the behavior of the fraudulent partners or the publishers, to identify their common patterns and to get insights into their fraudulent behaviors. And it has been identified from the literature that there's a lack of comprehensive study on the features so that towards identifying the fraudulent behavior of the publishers, and they were not robust in identifying the evolving behavior of publishers also. Here comes the problem description. One of the vital challenging issue towards identifying the fraudulent behavior of publisher is the conceptive. That means it has been identified a continuous change in the status level of the publishers. That means if a publisher, suppose a publisher has generated a click and it has been identified as a genuine publisher in the first week of the month, while the same publisher has been identified as a fraudulent one based on his click details which he has generated in the end of the month. So here we can see that there is a continuous change, there has been a continuous change in the status level of the publisher, which is termed as conceptive. Other than this, the various activities like generating duplicate clicks, making changes in the IP addresses, all these are termed as disguised activities of publishers which continuously harm the viability of internet advertising market. Apart from this, statistical user are models for detect fraudulent publishers content. However, the present large number of collinear, redundant, and significant features poses a challenge in investigating the publisher's behavior and increase the model complexity. The methodology. So based on the challenging issues which we have recently discussed, we have designed a methodology where our work aims to use potential features to address the aforementioned issue which we have recently discussed for identification and classification of illegitimate publishers. Here we have identified the publishers by evaluating the feature import utilizing the gradient boosting random forest logistic and XGBoost, where relative scores provided by the classifiers highlight the features that are at the most important or relevant and at least relevant to the target. The features with higher scores we kept while we have started this plausible strategy simplifies the issue being modeled and speeds up the modeling process while improving the model's performance. So here we can see in the block diagram that we have used the FDMA 2012 user click dataset. Thereafter, we have extracted the features from the dataset. Thereafter, we have identified the feature importances in these several classifiers, but we have got the superior results as in the gradient tree boosting. Sorry. Thereafter, we have evaluated the performance using the 10-fold cross-validation. And thereafter, we have classified the publisher as fraudulent or non-fraudulent. Here comes the results and discussion. Since we have identified the feature importance score utilizing the gradient boosting, XGBoost, random forest, logistic regression, and decision tree, we have conducted the experiment by utilizing all the features and the features selected. So superior performance based on the relative scores provided by the classifier, wherein GTB has outperformed the other classifiers. The same has been the result, the pictorial representation of the result has been shown in figure 3, where we have compared the performance of all features with the selected features. So here we conclude our work that the behavior of each publisher is addressed by evaluating feature importance scores provided by the standard machine learning classifiers. Here, noisy, irrelevant, and redundant features were discarded, and features with highest feature importance score we have kept. The literature pertaining to the final results strongly suggests that that our proposed model, that means gradient boosting, outperformed on the validation data set, as it reduces the overall prediction error of the model by combining the succeeding model, and it has achieved an average precision score of 64.86 with selected features on the dataset. That is FDMA 2012. So here are the references which I have gone through. Thank you for providing me the opportunity. Any questions?
Yes, can you hear me?
Yes, sir.
Yes. See, now your model, now when you're considering different click plots,
Yes.
now you're considering a particular database and making the feature extraction and proposing that, right? Now,
Yes,
how
sir.
many type of click plots your model?
Sir, my main work is to focus on the click fraud detection. That means the clicks generated by the publishers. So we have to identify the fraudulent publishers among the genuine ones. So in order to identify the fraudulent publishers, we have extracted the features based on their click details. That means the clicks generated by them. And we have extracted features like the number of clicks generated by the publisher in per minute, per second, then in hours also. And also we have divided the day into night, morning, evening, and afternoon time, and we have identified their behavior, and based on that we have designed the features, and thereby we have identified yes,
from
sir.
different frauds to different frauds. Obviously, this whatever the parameters or features you are getting, they are different, right? So
Yes, sir. Yes, sir.
can it be able to extend to every type of fraud or only specific type of frauds it will work?
No, sir. Actually, I have basically worked on click fraud detection only. These features are specifically for identifying the fraudulent behavior of publisher based on the clicks generated by them only.
Yes, click frauds only I'm talking about. In click frauds also different type of data bases you can get, right? Different type of parameters you can evolve here, right? So whether it can be extended to all type of click frauds, I mean the like different content
Yes,
based.
sir. Yes, sir.
Now, which classifier
Yes, sir.
you are using here?
Sir, I have used the gradient tree boosting, decision tree, random forest, logistic regression, and
Not
XGBoost.
for comparison in your model.
Yes, sir. I have also compared.
Now it's a binary classification you are making, right?
Yeah.
Finally,
Yes, sir. Sorry.
you have tried with all these classifiers separately, like you have used SVM,
Yes,
random
sir. Yes,
forest.
sir.
You
Yes,
have
sir.
done
Yes, sir.
an
I have.
ensemble map.
Yes, sir. I have experimented independently, separately with all the classifiers.
Have you tried with ensemble model of these classifiers?
Yes, sir. Our random forest is also an ensemble classifier.
How much accuracy you got?
Just a minute, sir. Sir, with random forest, if we have used the all features, then we received an average precision of 56.7, while we have received an average precision of 58.7 with the selected features provided by the random forest.
Now, similar models I have noted, somewhere some deep learning based click fraud detection models are there. I
Yes,
think
sir. Yes.
they have got better accuracy, I believe.
Actually,
I will
sir.
not compare it.
Okay. Actually, sir, I have not utilized the deep learning
Because
because
you are
for
getting
if I use the accuracy as the key measure, then the classifier will get biased towards the majority class. So rather utilizing the accuracy as a key measure, I have utilized the precision here.
then you can also try with these extreme learning machines and all. They will also be very effective for the accuracy slightly maybe
Yes, sir.
lesser compared to deep learning models, but they could be because you have a standard database, right, for your training model.
Yes, sir.
Obviously,
Yes,
this
sir.
will be
Yes, sir.
more effective because already
Yeah,
random
sure.
forest and ensemble type model, plenty of models for this fraud detection exist, particularly click for any other type of only the parameters differ, right, when you are talking about this.
Yes, sir.
Now,
Yes, sir.
similarly, other see since lot of this hallucinations involved here, you can also use some spam intelligence model. Genetic algorithms also could be one of the efficient classifier for detection.
Okay, sir. I will definitely try other classifiers also, like extreme learning and genetic
Because
algorithms also.
this genetic
Right now, not utilized.
algorithm effective compared to
Sure, sir.
conventional
Sure.
classifier in the
Thank you,
right
sir.
direction. Just a suggestion from my side, sir.
Thank,
Okay. That's all. It's a good
thank,
work, right? Thank you. And others, question chair.
thank you so
Okay,
much, sir.
am I audible?
A pleasure.
Yes, sir.
Okay. Suppose what I have been noticed here for this random forest, for this AP, you are having 56.7, and for the selected features, you are having 58.7,
Yes, yes, sir.
right? So it may not true for the other cases, but maybe it is true for some cases. So this difference is not a very high difference. So do you have any kind of statistical analysis to claim your simulation results?
No, sir. Right now, I have not applied any statistical analysis, but in my other experiment, I have applied other statistical test. But in this work, I have not applied.
Because it is nowadays it's very useful for making any kind of ANOVA or any kind of Friedman test, because every results what you have been getting simulation based in most of this area what you are talking of. So there should be a statistical significance for all these cases.
Yes,
Okay,
sir.
another
Yes.
thing in the last
Yeah.
part of your work, you have been noticed that so you have selected some high rank features. Okay, so for
Yes, sir.
selecting these high rank features, what are the criteria? What is your
Sir,
criteria?
sir, actually, our criteria that sir, the main use of the in identifying the feature importance score, because they has a significant contribution in predicting modeling. It gives valuable insight into the data in the model. It also provides basis to the dimensionality reduction and variable selection, which improves the efficiency of a predictive model. Actually, then it assigns scores to the features towards a predictive model, which defines the relative importance of every feature during the prediction.
Okay. And also one advice, you may also investigate like your some generative models like GANs, like generative adversarial network, or what Dr. Reddy has suggested, ELM. ELM is also an
Yes.
independent network, because the hidden layer complexity computation is very, very less, because there is only one hidden layer
Yes, sir.
in ELM.
Yes, sir. Yes, sir.
As
Sure.
compared to the traditional classifier, what you're talking.
Yes.
So maybe investigate some kind of generative models, ELM. So maybe you will achieve more accurate result or more enhanced result as compared to the traditional.
Yes, sir. Sure, sir. Sure, sir.
Okay, thank you very much. Nice work.
Thank you, sir. Thank you so much.
Can we go to the next presentation? I think paper ID 336.
It is.
Yeah, sir. So I'm sharing my screen. Yes, sir. My screen is visible, sir.
Yes, we can see.
Very good afternoon, sir. I'm Dr. Rajesh Srivastav from Bennett University, and this is my one of the currently running project. So here in this project, I'm just trying to modify the naive-Bayes algorithm, because the naive-Bayes is you basically a supervised learning technology, and the data that I have is a unsupervised, unlabeled data. So I'm just trying to experiment with the naive-Bayes algorithm, whether it is working for the unlabeled data or not. So this is a statistical data analysis basically. So basically, whenever I start this research work is collecting the attacker's data through the honeypot and in the IoT devices. So I'm using the Raspberry Pi IoT devices where I deployed the Kaori honeypot and collect the data. So the very first thing is that how to establish a framework inside the university campus, so it will not harm to the university network, but I'll collect the data. So I deployed the Kaori honeypot over the IoT device and give a separate IP to them, and the honeypot will collect a lot of data for me. And basically, what happened in the IoT network, once we deployed the IoT and collect the census data for the future references. So once we deployed, nobody can touch; they are left untouched, and the malicious things or the attackers have it's a soft target for the IoTs. They can come and they can modify the data or the program running onto the devices, and they can steal the sensitive information. So attack detection and prevention of IoT devices is a challenging one. And once we collect the information, we have to prepare an efficient IDS system that will help to prevent the entire IoT network, because once IoT network compromised, then there is no meaning of the collection of data, or the no meaning of any kind of automation. All things will be stuck, or maybe they give the wrong predictions. So for this particular thing, first we have to be collect the data, then perform some statistical analysis over there. But the most important thing is the collected data is unlabeled. So we need a mechanism that will help us to train or give a result from the unlabeled data. So as we discussed with my other colleagues, so we try to come up with we will try to modify or twist the naive-Bayes algorithm and figure out the probability and go for the clustering algorithm. So we will get the attacker records, and we come up with some novel solution. Okay, so we go with the literature survey what people will did earlier. So we figure out the people are using the machine learning techniques, but they mostly use with the supervised learning. They collect the data, they perform the labeled algorithm. They use the work that I already published with the same honeypot data that was for the game theory thing. So I applied the game theory model where, and I labeled the data for the particular purpose. So that is a very hard for me to collect the data and again label the data and then go on. So in this paper or in this work, we just modify the same thing. So our target is, our objective is that how to design an interactive interaction between the attacker and a honeypot in an IoT network, how we process the collected and unlabeled data in any suitable method. So we use the naive-based approach, and then we categorize the collected result, and we perform in a various categories, whether the data is benign or whether the data is a malicious. And then finally we come up with the interactive IDS system. So for collecting the data, we deployed the Cowrie honeypot, and whatever data we collected, we visualize the data through the Kibana and store that data into the server machine through the PostgreSQL. Whatever data we collected, we verify whether the collected IP is malicious or not. So for that particular purpose, we use the virustotal.com. Virustotal.com is a public website that is used by the antivirus engines as well as the attackers to deposit or to report the malicious activity or malicious IPs over there. So we also verified the collected IP, whether the IP is really malicious or not. So for the benchmarking thing, we use the VirusTotal. And then we have deployed the honeypot for the 40 days and collect approximate 2.2 million records in a JSON format. So the very first and tedious task is how to process it. So for that particular thing, we whatever data we collected, so we perform a probabilistic or the statics function over there, where we deploy simple Bayes theorem. We applied simple Bayes theorem. So whatever the IPs of the adversaries coming, whatever the adversaries IPs coming into the system, we collect it as a X, and whatever the command they are executing through that IP. Because once IP coming into the honeypot system, they perform various commands over there. Some are looking for the vulnerability, buffer overflow vulnerability. Some are performing the DDoS attack. Some are looking for the IDs and something. So whatever command they are performing over there, we evaluate that command. So we consider as a Y parameter over there, and we collect the probability how many commands performed by a particular IP in a particular time. And we create a data set or create a database where we collect all the commands performed by the adversary and the IPs. And later on, we will figure out whether the command is malicious one or the only just for the benign one. They come to the system and go out, because sometimes some research bots are also working over there. So they come to the device and just look, but they are not performing any kind of commands over there, and they go back. So we have two category of data, benign and the malicious. So we initially, for the beginning purpose, because in the naive theorem we need a probability score. So for the initial beginning purpose, we assume that the probability of X and Y is equal to 1, because all data is attacker's data. So without loss of generality, we assume that the all commands are performed by the attacker. So we give the same probability to all the data that we collected. Now for the likelihood function, that is a Y divided by X, we simply calculate the count of words, how many commands they performing. So each commands we consider as a word, and we will see how many attacks we will find into the database. So and how many repeated commands we have. So on the basis of that, we calculate the likelihood function, and then we have a probability score for that. Some malicious command coming repeatedly by a particular IP, so we know that okay, this IP is a malicious IP, and that IP is going into the malicious category. If the IP is coming and not performing any command, or just performing some simple commands, looking the directory structure or something, so we consider these are the research bots, so they are the benign one. So our proposed method finds the malicious IP by calculating the term frequency of uncommon words used by IPs, particular IP. So we calculate the overall frequency, and then once we have a probability score, then we go with the clustering algorithm, that is a k-means algorithm, that will divide the whole data set into two parts. One is a benign part and one is a malicious one. So as per the result, we figure out that we achieve only 136 malicious IP, and rest are just coming the benign. They come into the system and the honeypot system, and they just look to the network, but they are not performing any critical or crucial commands over there. Some malicious binaries that we found, some are the examples. They look like this one. They look like the random numbers. Some malicious URL that we also verified with the VirusTotal. they are really malicious and they are performing some serious attacks, severe attacks onto the networks. And we compared our result with the other approaches where people are using the naive same algorithm, but they use with the labeled data. And where we perform with the unlabeled data, so we have two algorithms, one is a naive based and one is a k-means. So our achievement is almost near to 96%, that is at par the existing algorithms. And we are consistently looking to twist other supervised learning algorithm to get better result or increase the accuracy. But this is the one result that we are currently working on. So we published that work, we sent that work to MISP conference, and the work is continuously going on, and we are twisting some other algorithms also, and to see what they are giving to us. So as per the conclusion part, we deployed the IoT-based honeypot that collects the unlabeled data in the JSON format. And the research challenge we face, how to assign the probability score to the collected data. So that's why we twist the naive-based algorithm to work with the unlabeled data. And we use the frequency count for the various commands and IPs to build our hypothesis. And at the end, we come up with a strengthened IDS system, because whatever IP is malicious, we simply block them. And so our IDS is also strengthened with this approach. These are some reference that I used to make this presentation. Thank you. Thank you, sir. So I'm done with it. If you have any query, please ask me.
Yes. Can you hear me?
Yes, sir. Yes.
Yes. Now, why do you use this IoT-based honeypot here?
Because in my research area, I'm just working over the IoT devices, where I'm just making a IoT device for the university lab. So we are deploying the IoT devices into the lab, which will help us to perform the automation kind of thing, whether the light is automatically turned on or the AC is automatically turned on when the people are coming. So we are facing a challenge that if somebody's hacked the device, so the light will on throughout the night or something. So this is the one aspect of that research that we are looking for the security purpose. And for IoT, so we want to collect the specific data, because IoT is, once we deploy, it's already unused, untouched by the people, and it's continuously collecting the data. So we look for the IoT honeypot. So Cowrie is one of the most commonly used IoT honeypot that will collect the various data. So IoT is our testbed, and that is we are using for our research purpose. That's why we look for the security of IoT.
How the communication take place here, and where honeypot is installed here?
Honeypot is installed over the Raspberry Pi. The Cowrie honeypot that is specifically meant for the IoT devices. So we deployed over the Raspberry Pi, and every day we just transfer the data of a Raspberry Pi into the server, because in each and every day we'll collect almost a 1 GB kind of data. So we transferred the data to the server once or twice as per our memory card field. So that approach we use to collect the data.
But you also discussed about IDS in the presentation, right? So you're not using
Yes,
any IDS here anywhere?
Yeah, at the end, whatever the malicious IPs we are receiving after as an output of the particular machine. So we block that IP through the IDS. So there is one command for the IDS, that is a block, and we are giving the IP number. So our IDS system will block that IP to perform into the university network, because
So
this IoT
logically, you're
network is
using
totally
honeypot
separate from the
before
university
IDS, right?
network. Yes.
No, you're using honeypot before IDS logically here.
Yes, sir. Yes, sir. Yes, sir. Honeypot is just analysis purpose, which IP is malicious and which one is not. So whatever the outcome of the honeypot, we block that IPs for the university DMZ system, DMZ firewall.
I got it, but see,
So
using
this is the
honeypot before,
pre-work from before the IDS.
I got your point, but in the IoT architecture, when you use honeypot before the IDS, logically, see, once the honeypot can smell something like a possible attack type, then IDS job is very nominal, right? Then how this can be used together here? Can you just justify the usage of these two? In which order?
Yeah, honeypot is just to collect the attacker's data, because once we deployed the honeypot, so attackers are coming to the particular machine, because honeypot is spreading the tokens, and the attackers will know some juicy data is there. They will come to the device, and we collect the data as well as whatever command they are performing. And once we know which IP is malicious, so in our IDS, we just block these IP. If these IP is coming into the real network, that is a university network, a university IoT network, so we are blocking them previously. So this is the prevention measure. So whatever the output and IPs we are figure out, we are permanently block these IP to come into the real network. So that is the usage of IDS here.
Uh, Still just relook into using honeypot before IDS and then pre-trained models how you are making for detection of
Yes, sir.
intrusion.
If we apply IDS before the honeypot, so we never get attackers data because IDS already blocked them. The
That's
purpose of honeypot is to collect the attackers information.
no, yeah,
So
IDS
honeypot is a
itself.
separate network.
When the intruders can be identified by your IDS system without the help of
So
honeypot, also you
IDS
can
is an
do this.
intrusion detection system, but we have to be set the rule into the IDS which IP we should block. So IDS is working with the firewall. If we are putting honeypot after the IDS, so we will never get the attackers data. So to how to make the IDS strengthen, how to make the IDS more useful, more utility purpose. So we need to block the malicious IP. So from where we get the malicious IP? One firewall that is coming with the proprietary services. Suppose we purchase a firewall for some company, so they are giving their own firewall and the internal mechanism working over there to collect the malicious IP. But here in this research, we are collecting the malicious data and figure out the malicious IP through the research and then block these IPs in our IDS. So our ultimate output is to strengthen the IDS.
How do you identify this turn frequency?
Term frequency, that means whatever the whenever attacker is coming, they are performing some commands into the honeypot. Whether some are looking for the root ID password, some are performing some buffer overflow vulnerabilities. So we have a set of command executed by the particular IP. So we make a data set, whatever IP they are performing, whatever command they are performing, and in a Docker box, we execute the commands separately and figure out what is the actual output of the particular command. If the command is looking for the root privilege or performing some, figure out some vulnerability scanning, then we put them as a category of malicious one. And if command is simply coming and performing the ls, some research bot is coming, so we can assign them as a benign one. That means they are not performing any crucial or critical command which is interacting with the OS or the kernel. So for that thing, we
You
use
have a
the
lot of
stress.
unsupervised data,
Stress
right?
will give the exact output which command is going into the kernel for the OS.
Now you have a lot of unsupervised data. No? Why do you choose this probabilistic model like this naive Bayesian classifier, etc.?
Yeah, once we have a data, because we have a lot of data and we have to be categorize that data, which one is a malicious one and which one is a benign one. And the total data is unlabeled, and we have a we want to be perform the clustering. So we need a one method how on what basis we perform the clustering. So we decided that we go with the statistical approach, which one having performing
Can
the
you hear
more
me?
dangerous command over there, we make them a malicious one. So to making the base for the k means, we perform this statistical analysis and we twist the naive Bayes algorithm by assigning the term frequency.
Okay, Dr. Sweeney, sir, I think I'll hand over.
Okay.
Okay, Dr. Srivastava, am I audible?
Yes, sir. Yes, sir.
Okay. So simply this particular work suggests a binary classification. So can
Yes,
it be
sir.
extended? So can it be extended because we are mainly classify the benign versus malicious. So can it be extendable to multi-class also to different grade of malicious?
We are working on that. Instead of one class, right now we are dividing our data into 5 different classes as per the attack category. So we are looking for the DOS attack over there. If some IP is performing the DDoS attack or some IP is performing some malicious code tampering attack, we are if some malicious ID is performing the data tampering, trying to figure out the kernel activities. So we right now this work is currently going on. So we go with the multi-class, and we instead of 2 we are classifying our data in 5 different categories, 5 different attacks. And so maybe in the coming paper, we will go with the multi-class classification.
So as you categorically emphasize that you are using some kind of probabilistic network, that is naive base. But the real issues is what we have been suggested, and also nowadays it is a very critical issue that is called the weakly leveled or the on-level data. Okay, so yes, why not to investigate some kind of transfer learning, these kind of models to here, because they works well as compared to this traditional classifier. So have you gone through the transfer learning, all this kind of thing?
Yes, sir. We've seen the transfer learning case. We just build the models and try to deploy that model in our different devices, IoT devices, so the devices are able to detect in the real time whether the data is malicious one or not. But in the honeypot scenario, maybe we will consider your suggestion in the upcoming results. So we'll go with the transfer learning, because of the data. Honeypot is not deployed in the real network. No, honeypot is a separate one, and it is collecting data passively. And once we have a data, then we'll perform it to server. If we use the transfer learning, then it is good. So I'll take the suggestion, and I'll definitely try to deploy in. So the IoT device is already enabled to take the real-time data and figure out whether they're malicious or not. I'll definitely try the transfer learning in this, sir. Thank you, sir. So may I stop sharing, sir?
Yes. So maybe we can move to the next presentation. Thank you.
Yes, sure.
Yes.
Paper ID 429. Mr. Siddharth Rautre, please share your screen with your presentation.
Yes, sir. Or an organization, and it also enables extraction by planting the denial of service to either a system or resources of that system, which will then result user that he can't or he or she can't able to access his or her system. Now this works by ransomware. They work by using the asymmetric encryption to encrypt and capture victims resources, and then in order to decrypt and release those resources, a certain ransom is demanded by the attacker to the victim. Now, in recent times, ransomware is the most used attack vector as it is irreversible, and unlike other malwares, it is very difficult to prevent. Now, talking about the technicality, to implement this, a pair of public-private key is uniquely generated by attacker for encryption and decryption of these resources, where the private key which is required for decryption is provided by the attacker to the victim only after the ransom is paid. Now, these ransomware are spread through spams, phishing, or targeted attacks, after which the ransomware executes a malicious binary on the victim system, and that binary finds valuable files to encrypt. After the encryption, ransomware prompts the victim for a ransom and provides a specific time to make the payment and release the private key, on failing which the captive files are destroyed. So this is how the ransomware attack is done. Now, for the literature survey, I have surveyed on some papers. So the main problem I got with this literature survey is that most of the paper, they do not focus specifically on ransomware. They rather focus on other malwares or generalized all kind of malwares. So I just chose those papers which focuses, those recent papers that focuses basically on ransomware only. So Eduardo and his co-authors, they made a survey on detection techniques for cryptographic ransomwares, for which they used 63 ransomware samples from 52 families, and they tried to apply different techniques, and as a result, they found that ML techniques are found to be more effective than the other techniques. And further, by P. Zavasky and his co-author, they made an experimental analysis of ransomware on Windows and Android platforms, for which they had 90% of sample from VirusTotal and 8% they were collected from the public malware repositories. And also they found out that the significant number of ransomware families exhibit very similar kind of characteristics. Further, Takuzi and his co-authors, they studied on the detection of ransomware using support vector machine, and they used 276 ransomware and 312 goodware files. And they also found that that using SVM model, they got an accuracy of 97.48%. Mohammed Khamas, he studied on ransomware detection using random forest techniques, and for his model, he got an accuracy of 97.74%. Now, the problem here is that ransomware is a type of malware that is very hard to detect because of its unique attack style and unique behavior, making it a very challengeable task. Now, according to Chitoparambil, none of the existing methods can afford to completely detect and prevent ransomware attacks. And also, it uses very effective mechanisms of infection based mainly on techniques of like social engineering, like sophisticated phishing, baiting, scareware, pretexting, and etc. So ransomware data are primarily behavioral and they're exciting to study and analysis. So that's why I went on to research about the ransomware and how can we make a model which greater accuracy than the present than the we found the papers from the literature survey. Now, for the methodology part, we propose an incremental ransomware detection model using various machine learning techniques. And the goal here is to train the model by feeding the data set with no feature selection techniques at first, means we'll just feed the model to the classifiers as it is. And then to further optimize it, we'll apply feature selection techniques on the data set. And hence we'll try to improve the classification's accuracy. Now, for every feature selection technique, we feed the final features to different classifier model. And finally, we achieve a pipeline of techniques and model that gives us the best accuracy. Now, for the data set, the data set I use, it consists of historical data records of data breaches and ransomware attacks over 15 years from 2004 to 2020. And this data set is obtained from the University of Queensland repository. Now, this data set contains 43 features that define the characteristics, behavior, effect, nature, and aftermath of the ransomware attack. Now, the feature value in this data set is in a textual form, which further needs to be converted to numerical in further stages to be processed. Now, this dataset consists of 64 ransomware records and the remaining are benign records. So this makes this dataset a imbalanced dataset for which we have applied balancing techniques in for the slides. I will be telling about what are the techniques. Now, this study has also split the dataset into 70% and 30% of training and testing sets respectively. Now, talking about the pre-processing of this dataset, now since I said the dataset was in complete textual form, so in order to work with the dataset, first we have to convert that dataset to numerical form. Now, for that, like for every feature, we mapped the unique values to the data. For example, if a value has if a feature has three values like high, medium, and low, so we then map those values with like 0, 1, 2, and respectively. So that's how we process the data set from completely textual to numerical. And then for the imbalancing problem, we applied the SMOTE technique, that synthetic minority oversampling technique, in order to balance the data set. Now, for feature selection techniques, we've used 5 feature selection techniques, that is chi-square test, correlation coefficient, forward selection, backward elimination, and lasso regularization. And in order to feed that to the classifiers, we used k-nearest and SVM linear kernel, polynomial, RBF, and sigmoid. And then I used decision tree, random forest, and then multi-layer preceptor of that 4 layers. So to conclude my proposed architecture of this model, this study first comprises of 4 stages. First, in saying that it's pre-processing the raw data set, and then applying the feature selection technique on it, and splitting the data into training and testing, and then finally training the data using some machine learning classifier model. Now, first of all, we take the data set, and for the pre-processing part, we use we deal with all the null and AND values, and then we use a mode to balance the data set. And then we first just feed this direct data set into the classifiers, and then again we again use the data set to select to apply feature selection techniques, and then the achieved feature set from the after using the feature selection techniques, and then those feature set are fed into the classifiers in order to get the desired model. These are the results I got. Like these results are from when no feature selection techniques are used. And here I got a decision tree to give an output at an accuracy of 97.91%. Now, moving forward, for the part when I used chi-square as a feature selection technique, I achieved about 97.67 as a highest performing accuracy for multi-layer perceptron. And proceeding further, when I used correlation coefficient, I found out that here KNN gives us the best accuracy of 97.97%. And moving forward, for forward selection technique, I found out that random forest here gives the best accuracy of 97.97 as well. And moving forward, for backward elimination, same random forest gives 97.97% of accuracy. And then finally, with lasso regularization, I got I, I got an accuracy of 98.26% from random forest. Now, to conclude this, we aim at finding the best performing model that classifies if an attack is ransomware or possibility strain directly with different classifiers, like KNN, SVM, decision tree, random forest, and MLP. And then to further increase the performance, feature selection techniques, or applying feature selection techniques improve the performance of the model. Now, the model that gives the best performance is the model in which lasso regularization technique is used, and further for feature selection and so it gives an overall accuracy of 98.26%. Now, our proposed model gives achieves an accuracy which is higher than the accuracy achieved by the Takeuchi's model using SVM, that is 97, and Ban Mohammed's model using a random forest. Our metrics in our evaluated metrics, due to the skewness in the data of the data set, the important features are considered from the data sets, which improves the predictive accuracy. Now, these are the references I have used to prepare this presentation. Respected session chair, I am concluding the presentation. And if you have any questions, I'll be answering that now, sir. Thank you, sir.
Yes, can you hear me?
Yes, sir.
Yes. Which data set you have considered?
Sir, I have considered. Sorry, sir.
When you have taken the data
So
set
the data set is taken from the Queen's, the repository of the Queensland, whose reference is also mentioned here, sir. So the third one, that
15 years
yes, sir.
data you have taken something.
Yes, sir. Yes,
Where you have taken the
sir.
data you mentioned, right? What is the size of the
So
data?
the data contained 46 features, and after using the smoting technique to balance, it gives 3,000
What are
records, sir.
those features? Can you name some few of them?
Yes, sir. The features were like the impact, means the attack impact, and like the if the ransomware was paid or not, and it was.
Certain different type of features we have to take compared to the other
Yes,
type
sir.
of attacks, right? Now, which features you actually finally
So
take?
actually, I did not manually selected any feature, so I did that by using the feature selection techniques. So I totally first considered all the features that were given, and then rather than just using manual process, I used feature selection techniques to check the most relevant features.
You mentioned that it is
Yes, sir.
incremental, right? How? Just can you just
So
elaborate?
by the means of incremental, I meant that I'm just using a step-by-step procedure of like first of all feeding the if at all we can improve the accuracy, or if at all our model is giving any performance, and then I'm using different feature selection techniques to see if we can further optimize the result. So that in that manner I'm stating that I'm taking an incremental approach.
You do you think it is really incremental in that nature, if you say? Because when you
Yes, sir.
tell me.
Yes, sir. So I was telling that I stated the term incremental in this manner, sir. Like the way I am conducting this study, sir.
That may not guarantee the incremental nature in the model when you are going to identify the different. I mean, this ransomware attacks in the different type of other data in the incremental
Yes,
nature.
sir.
Now, accuracy I think is increased. I think 1 or 2%
Yes, sir.
hardly, right? Already existing models, how they are giving around 97 point something, right?
Yes, sir. So the
Accuracy.
highest is a Ban Mohammed. The highest is a Ban Mohammed. That is 97.74.
Your model?
So it's 98.26.
Okay. Now, some little bit of accuracy we have seen. There is some improvement. Other than that, what are the other features of your model? Because accuracy
Yes,
almost
sir.
like close, somewhat better. What are the other features of your model?
Some other features are when did the attack was recognized, like after or before, and if it is done through any kind of IP or any kind of clickbait or anything, and if the attack like how big it was, and if it is to an most used on any organizations or individual attacks. So these kind of behavioral aspect of data set, sir.
This particular accuracy, what you consider is on the same data set, right? When you are compared with the existing. Now, unless you try, because there are some benchmark data set you have seen almost you got same accuracy, little
Yes,
bit
sir.
extra.
Yes, sir.
Now you should experiment on different type of data set. Then only you will come to know exactly how your model behaves as compared to the other one.
Yes, sir. So that is what going on for now, because this complete study is based on only single database and data set. So, and the problem with this thing is that for ransomware detection, I could not find any data set which is as good, or it could be like a very big data set and all. So the data set I'm currently using was the one I could work with now. And for the work for the work that will be going on, I'll be using it, sir, for different data set, and I'll be checking if it gives the consistent result or not, as you are
Okay.
suggesting, sir.
Okay, that's fine.
Yes, sir.
So, sir, I think you can continue, please.
Thank you, sir.
Okay, Siddharth.
Yes, sir.
Am I audible?
Yes, sir, you are audible, sir.
Okay, Siddharth, you have presented that with different feature selection like your chi-square or lasso or
Yes, sir.
backward selection, whatever it may be, followed by with different classifier, you have shown some accuracy results. Okay.
Yes,
So
sir.
I will ask you a very basic questions. Maybe we are showing with this feature selection, with this classifier, this much result, with this feature selection, with this classifier, this much results. So can you tell me, suppose you will consider the feature selection as chi-square and the feature selection as
Yes,
the
sir.
lasso. So how many number of features you have considered in both the cases? In
Yes, sir.
chi-square, how many features you have selected, and in lasso, how many
So for
features you have
chi-square, it gave me an output of 31 features out of 46. And for lasso, it gave me around 24 features from 46, sir.
Okay. And for the rest of the three, they are very much close, or there
No,
is
so there's
a
a huge difference,
means
because for forward selection and for backward, it also gave around 20 features, and for Pearson correlation, it gave around 36 features.
then as compared to the reduction in feature, what is the enhancement in the accuracy? Have you done it? Means whether it is a slight difference in accuracy or there will be a large variation in the
So if I consider like for each feature selection, like all the eight classifiers I'm using, if I'll consider yes, sir, for every feature selection technique and to the respective classifier, so there is just a difference of 1 or 2% of accuracy among them, sir, among every technique, sir.
Okay, understood.
Yes, sir.
Thank you.
Thank you, sir.
Siddharth, I'm audible.
Yes, sir, you are audible, sir.
Siddharth, have you tried out the multi-stage feature selection or feature selection followed by another feature
No,
selection?
sir, I have not tried that, sir.
Same in case of a classifier, multi-stage classifier.
No, sir, for multi-stage classifier or techniques or feature selection techniques, I have not considered on working on as you're suggesting, sir. But I'll sure be doing that now, sir, as you're suggesting.
Okay. In the regularization parameters, how many parameters have you considered in the last four regularization?
So at last, I'm considering just if I remember, just three or four parameters, sir.
Namely, can you name them out?
Sorry, sir.
Can you name them out, or can you just describe what exactly the features were?
Sorry, sir. Actually, I am not remembering it for now, sir. But I can check and tell if you will allow me, sir.
Okay. Thanks, Siddharth. That's from my side. Thank you.
Thank you, sir.
Thank you all
This is-
session chairs, Dr. Sumesh Srivastava, Dr. Damodar Reddy, and Dr. Suvendu Rup. Thank you for sparing your valuable time and giving fruitful session to participants and properly evaluating all the presentations. We hope your similar cooperation in future conferences, and we hope we will meet physically sometime when we organize next conference. Thank you for your all support which you have extended during the conference in review process and the session chair. So I request you to fill the evaluation sheet which we have shared, Google Sheet. Review buttons are there for evaluation of the paper so that we can declare the best paper of the day and tracks. Thank you all. Thank you participants for delivering knowledgeable and research findings.
This is my kind request to each and every participants and dignitaries on their video for the group photo. Please on your audio, video. Once again, thanks from the on the behalf of National Institute of Technology and MISP-2020. Sir, can I leave the meeting for this session?
Yes.
Thank you.
Sorry to interrupt. In this meeting only, session 5 is going to